Okay, question 7 here. Recruitment company advertises vacancies on their website. Information on the salaries for 36 of their vacancies are given in the table below. The data have been grouped. For these salaries, calculate the mean and also calculate the sample standard deviation. Okay, some things that I want to do straight away. I noticed that I've only been given lower limits for each of these intervals, but it would make sense that actually each of these does go up to the interval above. So this is 20 to 25, this is 25 to 30, 30 to 35, and those are the values that we should think of as, okay, I'm trying to find an estimate of the mean. To go ahead and find an estimate for the mean, I'm going to need some midpoints. So we're going to take the midpoint of each of these, which I will state here, 22.5, 27.5. Okay, so I'm ready to go for this calculation. So an estimate for the mean is going to be x bar equals the sum of all of the frequency times midpoints divided by the sum of the frequencies. Okay, so this calculation so each of those midpoints multiplied by their frequencies and all divided by 36. I was told in the question that there were 36 salaries we were working with. Okay, calculator work. Let's plug this all into the calculator. Okay, and that leads to 36.25. Thinking back to the context of this question, we were working on people's salaries, so 36.25 doesn't sound like much of a salary at all. It's because it's in thousands of pounds. So this is the answer to the calculation, but in context, I would actually like to see 36,250. Just demonstrating you know exactly what the question was referring to, rather than just blindly doing maths. Okay, so the sample standard deviation. We spoke about this in the previous videos. Since it's the sample standard deviation, we're going to divide by n minus 1. We're still going to need to calculate s of xx, and at some point we're going to divide by minus 1. Okay, so the s of xx is going to equal the sum of f times the midpoint squared minus n x bar squared. So n times the mean squared. If we're smart, we'll notice that this sum of fx squared is very similar to the sum of fx. So if you still have that on your calculator display, or you can go back a step on your calculators, you simply just need to add in squareds for each of those midpoints. It will save you a little bit of time from re-entering the whole line. So here, I'll just add a squared as necessary on those midpoints. Re-enter that to your calculator, and we'll need to subtract 36 and the mean squared. I'm going to go back to the fraction, just knowing that fractions do maintain accuracy, whereas decimals don't always. True, in this case, I had a terminating decimal, but in a different case, I may have rounded, and just out of habit, I go back to the fraction to make sure I have that accurate value. Okay, let's go ahead and work that out. Putting that all into the calculator leads to an SX value of 9,675 over 4. Okay, so we were looking for the sample standard deviation, which is going to equal the s of xx over n minus 1, all square rooted. Okay, what's that actually going to be? Let's substitute those values in. S of xx, that fraction, as we said, I'll write the decimal. Don't really want a nested fraction. All over 35, and that should give us our standard deviation. And that leads to a standard deviation of 8.3131. Obviously, once again, contextually, this is £8,313.10. So that's our sample standard deviation. Okay, the next part of the question asks to explain why these values are only estimates. The reason that they're only estimates are because we had group data. And when we had group data, to do any meaningful calculation, we need to make an assumption. And that assumption was that all of the pieces of data could be represented by the midpoint. Looking at the first group, where the salaries were in between 20 and 25, for the sake of my calculation, I've used 22.5. But actually, all of those salaries could have been exactly 21,000, which means that my value isn't exactly correct, but is as correct as I can be. It's as correct as I can be because I've made an assumption to use the midpoints. Okay, putting that into a sentence, because we had to use midpoints for the calculations as the data was in grouped intervals and we have no confirmation of the original data values. So next we were asked to give a reason why it would not be appropriate to use the mean calculated in part 1 as an estimate for the mean salary of all vacancies in the country. Well, that would be because we're using data that's specifically about this recruitment company, and to try and use that for the rest of the country wouldn't make sense. There are some industries where the salaries are a lot higher, and there are some industries where the salaries are a lot lower, and there's industries where the shape and the distribution of those salaries are once again very much different. So these estimates we've made are only applicable to this set of data. Using it outside of this set of data would be extrapolation, which we want to be wary of. And the way to sum that all up is that this set of data may not be representative of all of the vacancies in the country. Okay, and the last part of the question for today, another vacancy has an annual salary of 52,573. This was not included in the table. Without further calculations, state how the mean salary will be affected if it were to be recalculated using this value. Okay, remembering that X bar at the moment, so the mean that we'd already calculated was 36,250. If I was to involve this salary of a larger value, what effect would it have on the mean? Well, it's going to increase the mean. Any value above the mean added to the data set will increase the mean. Any value below the mean added to the data set will reduce the mean, and any value that is the mean added to the data set would have no effect. So it is going to increase the mean if we were to include this value.